Hello everyone, this is Milo and I hope I don't get everyone bored at the end of this problem, which is a problem from the Brazilian Mathematics Olympiad, specifically the first stage, which is called Competição Elon Lages Lima. And we have this limit here. We have to calculate this, but there's a problem. We don't know who s of x is, so the limit is s of x over x when x approaches the infinity. We have to know who is this guy. So first we define s of x as the sum of all f of n when n is less or equals to x. What does it mean? I got really confused in the exam. It was like 5 minutes, 10 minutes trying to understand this notation. So we have s of 0 equals to f of 0, okay? S of 1 means f of 0 plus f of 1. And so it goes. S of 2 equals to f of 0 plus f of 1 plus f of 2. Okay? Okay, this is the pattern here. And who is f of 1? F of n. F of n is a function defined from the naturals to the naturals. So it means that only a natural number can go in the input, and as the output, we can get either 1 or 2. 1 if n is an even number, and 2 if n is an odd number. So therefore, this is our problem. What's the strategy here? The strategy here is just to take this s of x and try to change it to something else. I don't know, x squared, x cubed, I don't know, like half of x. So we can cut with these x in the denominator, okay? So let's try to find an explicit rule for s of x. So as I told you, s of 0 equals to f of 0, okay? S of 1 equals to f of 0 plus f of 1. And so it goes. Yeah, we have s of 2, f of 0 plus f of 1 plus f of 2, and we have the f of 0. 0 is even, therefore this is just 1. This is 1 and this is 2, therefore this is 3. This is 3 and this 2 is even, therefore this is 1, and so we have 4 here, and a pattern begins to emerge. Then s of 3 equals to 6, s of 4 equals to 7, and s of 5 equals to 9, s of 6 equals to 10, s of 7 equals to 12, and s of 8 equals to 13, okay? We have this pattern here. It's not a pattern, clear pattern that we have here, but we can write this in some other ways. Like we have this one. Let's just erase this part since it became clear what we are doing here. So this is s of 0 equals 1. For fuck's sake, 1, 3, 4. 1, 3, 4. So we have this, okay? If we have 0 here, we can say that 1 equals to 0, okay? 0 plus 1 to get to 1. We can say too that if we have 1 here, we can put this 1 here and add 2 to get to 3. Okay, and we can do this for all the following numbers. If we have 2 here, this equals to 2 plus 2, and then we get to 4. This is equals to 3 plus 3, so we can get to 6, and this is 4. I hope you begin to see the pattern. This is 4 plus 3. I guess I wrote a lot of numbers. I guess it was too much for me. I don't know. It's too much. But it's good to see the patterns. This is 6, 7, 8, and we can put this as 6, 7, and 8. And we just have to sum here with 4, here with 5, and here with 5 again. Okay? The pattern isn't clear because we have first to divide this between even and odd numbers. And I say specific to the input. So we have even numbers in the input and odd numbers in the input, and we can change this to have only even here in the left and odd numbers in the right. So we have this, okay. We have this, okay. And a pattern begins to emerge clearly as the water. So we have s of x here. Notice that 8 equals to 8, which is the first term for this number here. We can say that 6 equals 6, 4 equals 4, and so it goes. And we have, therefore, the s of x equals to x plus something. I don't know. But this something, like this 5, what the fuck is this? We have to take this 8, we divide by 2, which is 4, and we add up 1, and we get to 5. We can do the same for every other stuff here. If we have 6, we divide by 2, we get to 3, 3 plus 1, 4, okay? We have 4, we divide by 2, we divide by 2, and we add 1, and we get to 3, 2 plus 1, 3, okay? 2 divided by 2, 1, 1 plus 1, 2. Therefore, the rule is, we take the number, we divide it by 2, and we sum with 1, okay? This is our pattern, and we can rewrite this as 3 over 2 times x plus 1. And for the odd numbers, it's a similar pattern. We have s of x. This number is the same as this number, but we have something else in the right that we don't know yet. But what is this number? This number is, if I take 7 and I add 1 to it, we get to 8. We divide it by 2, which is 4, and we add 1, which is 5. I'm gonna do this algorithm in all the s before this. So we have s of 5. 5 plus 1 is 6. 6 divided by 2, 3. 3 plus 1, 4. We get to this guy. We have 3. 3 plus 1, 4. 4 divided by 2, 2. 2 plus 1 is 3. And we have 1. 1 plus 1, 2. 2 divided by 2 is 1. And 1 plus 1 is 2. And therefore, we have that this is a number, this number, x, plus 1. And all this divided by 2. And at the end, we sum 1. And we can rewrite this again as 3 over 2 times x plus this time 3 over 2. 3 over 2. So we get that our limit, when we can call this, okay, we can say that s of x divided by x when x approaches the infinity is equal to 2 cases, okay? The first case is when limit of 3 over 2 x times 1 divided by x when x approaches the infinity. And we have the other one. Instead of this one, we call it 3 over 2, okay? But this is for even numbers. And this is for odd numbers, okay? We have this, we can rewrite this simply as limit of when x approaches the infinity of 3 over 2 plus 1 over x. We can just make this and make this, okay? And when x approaches the infinity, this approaches 0, and therefore this is just 3 over 2. And the below is limit of when x approaches the infinity of 3 over 2 plus 3 over 2x, following the same train of thought, and we get as well to 3 over 2. Therefore, our limit is just 3 over 2. And we're done.